We're going to talk about Ohm's law, whatever that is, but we're going to get around to it in just a second. So we said in the last video that current or electrical current was the amount of charge that flows per unit time through a spot. Okay. We'll talk about how we measure current a little bit later practically, but that's what it is. Now, the question then becomes, well, how much current is allowed to flow? Well, remember, we're talking about charge. That charge, we said, exists in the path already, and it's just a matter of forcing it to flow. So there are two factors that affect how much current flows then. So how much it is being forced, and then also how hard is it to pull the electrons off the atom to force to flow. Because some things hold on to their electrons more tightly than other things do. So how much it is being forced? Well, we talked about before, what's determining how much it's being forced is the potential difference supplied, which is another way of saying the voltage supplied of the source. All right, and so if I have a stronger voltage source, I get more current. And so that's a direct relationship, right? More voltage supplied, more current, right? That should make sense because I push harder, then I'm going to dislodge more charge and cause it to flow. Then how hard it is to pull the electrons off the atom to force the flow. I talked about something in the last video called resistors. Well, resistors have a property which is called resistance. And resistance is a measure of how hard it is to force electrons to flow, okay? The higher the resistance, the harder it is to get them to flow. Now, interestingly enough, we said resistors did useful things, though. And that's a little bit about life, folks. There's a saying that you don't get something for nothing, right? That if we want these electrons to do useful things, oftentimes they are attached really strongly to their atoms. So the more that we force them through, the more that we can get them to do stuff, right? So that's why this word resistance was created, because it was created to talk about how hard it is to flow, but those resistors actually do useful things because we don't get something for nothing, right? So resistance is given a symbol. It is called R, capital R, and it's going to be measured in something that's going to be called ohms. If you read in the textbook, the ohm, named after Georg Ohm, who's someone who did a lot of work with this. The ohm, though, has a really funny symbol. It has the Greek uppercase letter omega, right? And it looks like a horseshoe. And so what it is that this is an indirect relationship. That the more resistance a circuit has, the less current that flows. So that's your trade-off. Like, I want it to be able to do good stuff, but the more resistive it is, the less current that I get to flow. So depending on what you're trying to do, you're trying to find a balance between those things, okay? Just to illustrate some of these ideas, right? Different batteries have different voltages. For example, this is a 6-volt battery. The AA battery is a 1.5 volt battery. You'll notice that the light bulbs that at home that you saw using the 1.5 volt battery were not very bright at all. This was brighter because it is causing more charge to flow. It's also 6 volts, giving each charge more energy, right? So this is 1.5 volts. This is giving each charge 1.5 joules, and this is giving each charge 6 joules. And even more than that, not only is it giving more energy, but this forces more charges to flow than this. So you get a lot more out of higher voltage devices, or higher voltage sources, than you do over lower voltage sources. But we'll come back to that notion. So I talked about something called Ohm's law. So Ohm's law is what is combining all of these things. We said that there was a direct relationship between voltage supplied, so this is voltage supplied, I'll just say that's our symbol for voltage supplied, and current, right? And so that means that the current is directly proportional, right, to the supplied voltage. But the current, we said, was inversely proportional to the resistance of the circuit. Okay? Indirect or inverse. That when you put these things together, you get that the current that flows is the ratio between the supplied voltage and the resistance of the circuit, right? So that would be in the circuit that I made here that we saw, the resistance would be the light bulb, the resistance of the light bulb. We'll talk later about why certain things have more resistance than others. But that is the notion of Ohm's law, and then we can use that. So if I told you, for example, oh, okay, well, here's a 6-volt battery, and you read on a device that like it needs 1 amp of current in order to work. And you can see this on devices if you just turn them over, right? So if my source had 6 volts as its supplied voltage, right? And we know that it needs a current of 1 amp in order to function, then what could you plug into that? Well, solving for this, we can see that I would be 1 amp, and the voltage is 6 volts, and then the resistance, we could solve that, and then we would get 6, but 6 what? Resistance is measured in ohms. That means that that device that plugs in to get that 1 amp has 6 ohms. And that's the way that we do Ohm's law, by using this proportion. But it should make sense. The stronger I push the charges, the more charges that flow. The more I hold on to charges, the fewer charges that hold. So we're just going to play with these notions this week. And then what we're going to do is next week we'll talk about, well, what gives some things more resistance than others? Like, why would one object have more resistance than others? And then we'll also talk about that idea of, the output as well. We talked about why some light bulbs are brighter than others. And so we'll talk about that notion of brightness of the light bulbs as a replacement for what's going to be called power next week. And then the last thing we're going to do next week is start talking about circuits that don't just have one thing in them, that they have multiple things in them, and multiple resistors in them. And in order to help with that, we're going to learn something called schematic diagramming to draw circuit diagrams. And then that's where we're going to leave it off.